Hello, in this video we are continuing our discussion of section 7.2 on volumes. Specifically, we're talking about solids of revolution. We're going to find the volume by using the disk method. In example 2, we have R is described as the region bounded by the curve y equals the square root of x, the x-axis, the y-axis, and the line x equals 4. And we're asked to set up but do not simplify or evaluate the integral that calculates the volume of the solid of revolution obtained by revolving R about the line x equals 4. The first thing that I want to comment on is the instructions here to set up but not simplify or evaluate is something that you should get familiar with because you will see it again in the future on quizzes and tests especially. The reason for that is these applications of integral problems, your knowledge of that can be tested completely by just setting up the integral. So it takes less time, more problems can be put on a quiz or a test in a shorter period of time, and I can test you on all of the applications that way. Now, just like the previous example, you may be asked to set up and evaluate to actually find the volume or the area or whatever application we're talking about. So you can't completely forget about integration techniques that we talked about in the previous chapter, but you should also get used to just simply setting up the integral. And if the problem specifically says to not simplify or evaluate, please follow those instructions as it will save you quite a bit of time. So in this example, we're going to work through the problems pretty similarly to the, work through the steps pretty similarly to the previous example. We're just not going to evaluate the integral that we get in step 4. So the first step is to sketch our region. So we have the curve y equals the square root of x. That's going to look something like this. We have the x-axis, which is the same thing as y equaling 0. We have the y-axis, which is the same thing as x equaling 0. And we have the line x equals 4. So that's going to be a vertical line here, x equals 4. This intersection point is very important. When x is 4, y is 2 because it's on the square root of x. We'll also have an intersection at the point 0, 0. The region that is bounded by all of this stuff is going to be this region here. So we're going to take this and we're going to rotate it around the line x equals 4. So then, if we draw a line segment through our region perpendicular to our axis of revolution, that little line would be rotated around the line x equals 4, and you can imagine it would form a circle. So this is going to be our radius. Now, our axis of revolution is parallel to the y-axis. So this means that we need to integrate with respect to y, okay? So that means that we should probably rearrange our function so we get x equals y squared. We're going to have x equals 4 also. So then our radius will be r of y, and in words, it's going to be the distance from this line, x equals 4, and x equals 4 comes from our axis of revolution. So it's the distance from x equals 4 to, to x equals y squared. Now we're talking about a horizontal distance. In the previous example, we had a vertical distance, so we did top minus bottom. With a horizontal distance, we want right minus left. So right is 4. Left is the y squared, so we're going to have 4 minus y squared. Our bounds of integration, I'll go ahead and use c and d since we're talking about y values. C is going to be the smallest y value, so that's going to be y equaling 0. So c will be 0. D is the largest y value, which is up here at 2. So putting all of that together then, the volume is going to be the integral from 0 to 2 of pi r, which is 4 minus y squared, all squared dy. And this is our final answer for this example. Notice if we were asked to actually find the volume, so we would need to evaluate this integral, the only way to do that would be, well, the easiest way to do that would be to square out 4 minus y squared with some algebra. But you should also be able to use a trig substitution here as well, but I highly recommend using some algebra to square out 4 minus y squared and then integrating that way. But for this example, this is all we need for our final answer.